All right, guys, everybody up here? Okay, guys, so this is the second derivative test. That's what we're looking at today. Obviously, to get to the second derivative, you still have to do the first derivative. You guys go ahead and shut your laptops. We don't need them right now. Thanks. Some of you on your test grading the free response, some of you tried to do every derivative with the limit definition of the derivative. Please do not do that, okay? It will take you forever to do all of these derivatives. So use the shortcuts, do those things that you know for derivatives. So we're going to build on the understanding of the increasing, decreasing max and mins and add in concavity and points of inflection today, okay? So it very much builds on what you did in unit 10. All right, so the second derivative test, what it tells us. This tells us about the concavity of the graph. And that would be of the original graph. So f of x if we're dealing with f double prime. So if f double prime of x is less than 0, so the second derivative is negative, we know f of x, the original function, is concave down. Concave down looks like that. If the second derivative is greater than 0, you can probably guess f of x is concave up. And if f double prime equals 0, you may have a point of inflection. And guys, a point of inflection, that's when it actually changes concavity, like from concave up to concave down. Wait a second here, let you get caught up. So just like we had critical numbers, those values where the first derivative was equal to 0, undefined, that sort of thing. And then we would do our number line test. It's the same idea here, but with your second derivative. So let's try one. All right, so I'm going to give you f of x is equal to 2x cubed minus 3x squared minus 12x plus 8. So that's your original function. So we're going to find everything with this. We're going to find where is it increasing and decreasing, where are your max and mins. Where is it concave up, concave down, and points of inflection if they exist. Okay, so where do you think we need to start? Yeah, we got to find the derivative. So let's do the first derivative part first. So what is f prime of x going to equal? 6x
squared.
Yep. Minus 6x. Okay, good start. Well, before we do that, because I want to know about increasing, decreasing max and min. So what do I need to do with this first derivative? Set it equal to 0. Okay. And guys, can I factor the 6 out right away? We okay with that? So what does the x squared minus x minus 2 factor into? X minus 2, x plus 1. Okay, so what are your critical numbers? 2 and negative 1. So what do I do with that 2 and negative 1? Eventually. We will plug them in eventually. What about a number line, guys? Okay, those are the numbers that go on my number line. Pause here a second, make sure we're caught up. Okay, what is easy to plug in that I can use this time? 0. And again, I'm plugging it into that factored form. So 0 minus 2 is negative. 0 plus 1 is positive. So overall, that is negative. Will my number line alternate? Yes. Why?
No multiplicity.
Thank you. No multiplicity. Okay. All right, what do the pluses and the minus tell me?
There's pluses increasing, minuses decreasing.
Perfect. So if I ask you for the increasing sections, what would you tell me? Negative infinity to negative 1. Good. And where else? Okay, perfect. Where is it decreasing? Good. All right, and we do have a relative max and a relative min. Where does the relative max happen? Is it at the negative 1 or the 2? Negative 1, right? If you're increasing and then decreasing, that's what creates a maximum. So we know that happens at x equals negative 1. How do I find the actual value of that maximum? That's where we plug it in. Yeah, so plug your negative 1 back into the original up here. So I'll give you a second to plug that in. What do we get for the maximum? What did you say? Anybody else? 15? Yes, 15 at x equals negative 1. Ooh, sorry guys, that's unpleasant. Hold on, don't watch the flashing screen. Okay, there we go. All right, and then everybody okay with the minimum would happen at x equals 2? Okay, and then we plug it in to figure out what that is. Anybody have it? Minus 12, yeah, negative 12, good. Okay, that is all review. That is all the first derivative test. Okay? All right, we're gonna do the second derivative test. So we need to find the second derivative. What is the second derivative? Good. Much. What do you think I need to do with that second derivative? Set it equal to 0. And what do we get for x? 1/2. So that's a critical number, just like we did with the first derivative. You can make a number line again. There's only going to be one number on it. So there's 1/2. What would you like to plug in? 0. Yeah, what do we get when we plug a 0 in? Yeah, okay, so we get a negative here. What does that mean will happen on the other side? Positive.
If it's just a linear function, you have to look at
No, as long as you recognize like it's positive on this side and negative on this side, that's fine. So the x value is 1/2. Yep, and then we'll have to plug it in to find the y value. All right, so everybody okay up to this point? What this is telling you, when it's negative, that means the graph is concave down here, and then it switches and is concave up here. It's tricky to wrap your brain around the increasing, decreasing versus concave up and concave down. Because concave down, do you guys see how it could increase or decrease over that section? Same thing with concave up. So you have to separate those two things out. But I would ask you, where is it concave up and where is it concave down? So what would you tell me for concave up? 1/2 to infinity, right? Concave down, negative infinity to 1/2. And what do you think? Do we have a point of inflection on this one? Yes, it changed from concave down to concave up, right? That's what a point of inflection is when it actually changes from one to the other. Most of the time, your critical number will be a point of inflection. Not always, though, if there's some sort of multiplicity or something else going on with it. So your point of inflection, this you can write as an ordered pair. So we know the x value is 1/2. How do you find the y value? Okay, I'll give you a minute to do that by hand, okay? Anybody think they have it? 3/2, yes, okay. Good. Fractions in your head, plugging it in, sometimes that doesn't go well. So don't be afraid to write it out. Okay, what I want you guys to do now is take this information about where is it increasing, decreasing, max, min, concave up, concave down, point of inflection, and sketch this graph for me. Your X and Y intercepts don't have to be perfect, but I want you to sketch the rest of it. So just go down below it and make a sketch for me. Check with your neighbor, see if your graphs look the same.
It's taller than natural gravity. So
Yeah, where
All right, guys, there's my sketch. All I put on there was the max, min, and the point of inflection, and I just labeled them. You don't have to go crazy with tick marks and making this perfect, just the general shape. Okay? Okay? Increasing to that negative 115, decreasing afterwards, changes from concave down to concave up at 1/2, 3/2, starts increasing again after the 0.2, negative 12. Okay? Would you guys agree that this part up here, like this stuff, this is easy? Yes, okay. Yeah, the second derivative test, figuring this part out, just telling me, oh, it's concave up here, concave down there, that's easy. It is the graphical part of it that is sometimes tricky for you. Like what I'm going to give you on the next one is a sketch of f of x, and you have to sketch f prime of x and f double prime of x based on the original. Okay? Your brain might hurt a little bit after this one. So given f of x, sketch f prime of x and f double prime of x. I want you guys to work together and talk to each other and figure all of it out. All right, I gotta find my original. There you go. No points. Think about what the first derivative tells you. Draw that one. Think about what the second derivative tells you. Again, this will take some time, guys. Don't rush through this. Think about it.
Is this a two with the cosine sine graph?
Nope, not a cosine or sine graph. It's a quartic graph. Right? Fourth degree, both ends go down. 3 turning points. You don't need to know how to graph that. You need to know what the first derivative would tell you about this. What would the first derivative graph look like? Now, remember to think about critical points. Where do they come from? What do they tell you? You can do it algebraically. It's doing it graphically that's harder.
Which side is higher?
Does it matter?
I think so.
It does not.
Can there be more than one or less than that?
Yeah, that's the point of relative. It's like within this little window, it's a maximum. I know it's hard, guys. Keep trying. Think back algebraically. Think how you found your critical numbers, your first derivative, where it was 0, what was happening on the original graph?
We don't know those.
Yeah. Doesn't matter. You can draw it still. You're not algebraically figuring this out. You are graphically figuring it out. These points matter for figuring out your first derivative. Okay? All right, guys, my continued nudging. We've got a maximum over here on the left. That means your first derivative is equal to 0 there. So these 3 points are of your first derivative. You got to figure out how to connect them. What is happening? Now, when you get to the second derivative, you can either think about the concavity or you can repeat what you just did, only from your first derivative graph. Yeah, I'll give you time.
I was just trying to point of inflection.
Well, what did you notice about the point of inflection up here? How does it relate to the -1 and the 2?
Oh, it's supposed to be like the halfway.
You can also use your first derivative and think about where its maximums and minimums are.
I guess. It said like those are the points you use. Next is increasing, next
Are we ready, guys, or we need a minute? You're okay. All right. Is everybody okay with why these 3 red dots are on the x-axis? Okay, remember where your original graph has a max or a min, your first derivative is equal to 0. Okay, what is the blue graph here doing from -infinity up to that point? Okay, so where will my first derivative graph be? Above or below the x-axis? Above. Why? Like I guessed, I had a 50-50 shot. Why is it up there? I think this is hard for your brain to see, because when I draw this, this is what's happening here. Well, that's decreasing. Yep, that doesn't matter. It is above the x-axis, meaning it has a positive y value, which tells you your original is increasing. Okay? What is happening between these 2 red dots? It's decreasing. So where will my first derivative graph be? Below the x-axis, because it's negative. Like if you were doing the number line test, you'd get a negative in that part. That means the graph is below. So again, this weirds you out because it's going to be below, it's going to decrease and then increase, right? Because I got to connect to that other point. But all of that is below the x-axis. So all of those function values are negative, meaning your original was decreasing. What happens from this dot to this, like what is the graph doing? Increasing. So that all needs to be above the x-axis, but I have to connect back to that one. And what's going to happen afterwards? Yeah, going to continue down because f of x was decreasing, so that needs to be below the x-axis. So that is f prime of x. Let's pause there for a minute. Did your brain kind of explode just a little?
No, I got it.
You got it? Okay, good. Does it make sense now, though? Yeah. Matthew?
Wait, why is the left going down again? On the left side, why isn't it increasing? Why is it decreasing?
So if you made a number line, I don't know, we'll call this A, B, and C, okay? This is your first derivative number line, okay? That increases, we would have seen positive, negative, right? That means above or below the x-axis. So if I need to be above the x-axis for this, do you see it? Yeah, that's what's so hard. You're like, no, but it's increasing and I'm drawing a decreasing graph. Two different things. The original is increasing, the first derivative is positive. Okay, second derivative. There are two ways you can think about drawing the second derivative graph. You can look for the points of inflection on the original and look at the concave up and concave down. You could also look at the first derivative you just drew and think of that as now being your original, and then doing the first derivative of that. It would work the same way. We'll go with inflection points since that's kind of what we started with. All right, so it looks like an inflection point maybe happens somewhere right in here. Would you guys agree? Do you notice it's always halfway in between your max and your min? That's where the inflection points happen. And this one, I didn't mean for these to both be basically on the x-axis, but that's kind of what happened. So those are your inflection points. Do you notice how they line up with the max and min of your first derivative graph? Okay. All right, so the left side coming up to that first green dot, is that concave up or concave down? Down. So where does my graph need to be, as in above or below the x-axis? Below, right? So I'm going to be here. In between the two green dots, is that concave up or concave down? Concave up. So I know that is happening. And then what's the last section? Down. That is second derivative. And guys, are you seeing, like, the blue graph? Do you recognize that that's a fourth degree function? My red graph would be a cubic function. The green graph would be quadratic. Like, they should always go down 1 degree when you're doing derivatives, okay? And look, this one, the red graph, do you see how it's decreasing all the way to here? And the green graph is below the x-axis. It's the second derivative of the original, but it's the first derivative of your other first derivative. Does that make sense? It's a lot for your brain, I know. Okay, so look at that for a second. What questions do you have?
Could you do a triple derivative into the first derivative and the second derivative?
Yep. It doesn't really tell us much graphically, but yes, you could do. Ask you for the 17th derivative of something. You know, you can just keep going. Most of them, if they're polynomials, are going to be 0, depending on the degree. But questions? Which one? Sorry.
I'm just like trying to go from f prime to x down.
Okay, so decreasing below the x-axis. Increasing above the x-axis, decreasing below. Yep, you can always do that, because the green one is the first derivative of the red. Yeah. So guys, do you see what I mean? That like the mechanics of it, the algebraic part, it's not hard, but making sure all of this makes sense in your head with the graphs, that's the tricky part in this unit. Okay, that's actually the end of your notes. Your notes are short today, so. But we are going to do a quizzes that's all about graphs and derivatives.
I get that.
It makes sense.
Yes. Now that I understand the minus below,
Yeah, do you like that part's making sense now? Okay, good.
were there any AP tests today?
Yeah, there's some every day this week.
I actually want mine in a late period, so I'm gonna have one of them in like the 23rd and 24th.
That's unpleasant.